This video will review the basics of 3D solid modeling. I will follow up with a second video as soon as I have time to explain how you can start to modify those 3D solids in more advanced ways. Now, in my introduction to 3D drawing, I covered the basics of the view angles and visual styles. So that will be important, and I'll assume that you have already watched that as we get into the 3D solid modeling parts in this video. Now, the basic box I also went over then, but I'll review that quickly now. So I'm on the Solids tab of the ribbon, and you can hit your box tool. And basically the idea is you're drawing a 3D object, but as long as you're in a plan view, it starts out the same as drawing a rectangle. So I can click two diagonal corner points, and then now I just have to enter a height for the third dimension, in other words, the Z dimension. So I can type in a height now, and now I have a three-dimensional box. And then I'll use my view cube here to show you that. Now, most of the time, however, you're going to want to draw a box that's a specific size and not just two random diagonal points in terms of the size in plan view. So I'm going to hit my box command again and then click my first corner point. And now in order to enter the size in plan, I can do this a lot like drawing a rectangle by typing the @ symbol and then my X dimension, comma, Y dimension, and that will enter the opposite corner. So if I want it to be, let's say, 15 feet by 20 feet, I can do @ 15 feet, comma, 20 feet, and hit enter. And now I can enter my height. So maybe that needs to be 12 feet, and enter. And now I have my box, but it is a specific size. I can move it over here so you can see that a little easier. Now, the other way that you can control the size after the fact very easily is in the properties palette, because you can see there's three fields there for length, width, and height to control the size. So if I change my mind and I want this to be 14 feet instead of 15, that's very easy. Now, you have those simple properties as long as it's a simple box in the 3D solid form that you originally made it. Once you do some more advanced edits to it, then you're going to lose that ability to simply type in the numbers or parameters in the properties palette. Most of the other simple 3D solid tools are pretty self-explanatory. The cylinder, the cone, sphere, pyramid, wedge, and torus. For example, the cylinder, if you start that tool, it asks you for the center point, so you can click where that is. It asks you for the base radius. So let's say that I'm drawing a flagpole. My base radius might be 3 inches. And then the height, maybe that's 20 feet. And so now I have a long, narrow cylinder. So those are pretty easy if you just read the command line and enter the information that it's asking. Especially the sphere, because there's really only one piece of information for that, and that's, well, the center point for where it's going to go, and then the radius. So if I want it to be a large sphere, I can type 20 feet, and now I have a huge sphere. Now, the rounded shapes are always going to look kind of simple in wireframe view. So if I go to a shaded view, then you can see these a little easier as far as what you're drawing, like a realistic view, for example. It takes a second the first time you switch over to it. So now you can see, yeah, that looks a little weird in wireframe view, but it is a real sphere. So you just have to understand that AutoCAD is showing it in a simple manner in wireframe view so that your computer is running very quickly. So it's surprising how many things you can assemble out of multiple simple forms. Drawing multiple different size boxes you can assemble together to create more complex shapes. So that's very easy to do. Your normal commands like move and copy and all those things will work in the normal way with the 3D solid object. So if I want to move this and stack it on top of the other box, I can use the object snap point and then click on the top object snap point of that box, and now it's stacked on top of the first box. So all those things work as you would expect. It gets a little bit more confusing if you want to move things specific distances and directions. So in top view, everything's going to work exactly the same way as normal. You can slide this object over if I want. I can do my move command and slide it over 20 feet, and now it's moved over 20 feet. But if I want to raise something a specific distance and direction, how can I do that? Well, I could use the properties palette because it has your position Z right there, and that's controlling how high it is off of your zero plane in the Z direction. So that would work if I wanted to raise something. The other thing to be aware of, though, is how important your UCS icon is. And I haven't talked about that very much in my videos, but you might have noticed how it always points X and Y as your normal Cartesian coordinate system directions. Your XY plane, if you think about that as a plane, like a sheet of paper, is going to be your normal working plane. And so if you want to raise an object like this, you can use object snaps to do it, you can use the properties palette to do it, but if I'm in a side view, like left, for example, and I want to raise this, notice that I'm not working in the XY plane anymore because Z and Y are the two directions I can see. It's basically impossible to move this in the Z direction unless I use either object snaps to force it or the properties palette. So that's why the XY plane is so important, is because it controls your working plane, essentially. So you have to keep that in mind. You're always working in the XY plane. If you want to violate that, you can use object snaps to do it, or you can shift where the XY plane is actually located. So we can do that in a couple ways. Rather than relying on the view cube, if I want to go to a side view, I can also use the view tab of the ribbon. And now if I hit left, right, front, or back, it actually will rotate the UCS icon to be parallel with my current plane. So now you can see that X and Y are parallel with the screen of my computer, essentially. So now if I want to move this object, I can move it up. It's very easy. So you can use the view section of the ribbon in order to access these views, and the UCS icon will rotate to follow the view you're in instead of relying on the view cube. Not that the view cube is bad, but it does not rotate the UCS icon. Now if I go to isometric view, you can see that the UCS icon is still set to the original direction that it was, and the UCS icon is actually working in a different way. So you have to keep that in mind, that it relates what's top and what's back and left and right relative to how the UCS icon is arranged. If you want to reset the UCS icon back to the standard location, then use the World button on the View tab of the ribbon. World is the standard UCS icon orientation. So now everything is back to normal in terms of the UCS icon and how the view cube is going to work. So you also can take control of the UCS icon with those other icons right on the coordinates panel of the View tab. So for example, let's say I want to raise this box, but I want to do it in an isometric view, and I want to do it in a distance and direction, so I don't have any object snaps to use. Well, as long as X and Y are flat on the ground, then that's not going to work. But if I hit rotate around the X-axis, the one that points at the X direction there, I can hit that, and then I'm going to tap space to accept 90 degrees. Now it's rotated the UCS icon, so my X and Y plane is going up and down. So now when I move this object up, I'm actually moving it up, as you can see. So that's another way to take control of what plane you're working in. Now I can go back to World, and now X and Y is flat on the ground again. Otherwise you have to be careful. If I try to move this, it looks like I'm going up, right? But I'm actually not. I'm sliding it further away from me in terms of a horizontal direction on the XY plane. So you have to keep that in mind. If you're working in an isometric view, it's sometimes tricky to see what's going on. So you have to keep that UCS icon in mind in terms of what's happening. Now, the other really handy command when you're working for 3D solids is extrude. So if I have a closed polyline, notice I said closed, so I'm going to type C to close my polyline. And now I can extrude that into a 3D solid. So I can hit extrude, select my closed polyline, tap space because that was the only one that I needed to select, and now I can either click to determine the height, or I can type in a height. So you can take any closed polyline, and we'll extrude that into a 3D solid. Now all these shapes are pretty easy to edit after the fact if you use the grips that are available to you, especially the 3D box forms and other simple forms. They have grips at each corner and at each side, so I can extend this out in that direction and up in that direction. And so the grips do allow you to work in directions other than the XY plane. I mostly say that the standard move and copy commands, things like that, are what are very constricted by that UCS icon. So the grips make it very easy to enlarge or shrink down your shape. The corner grips also are very nice in that way. So the cylinder works the same way if I want to change the height. Just be aware of your object snaps. You'll notice I just clicked that grip and it went back to the original point. That's because my object snaps were on and it picked up that original object snap. So all of those are very easy to edit. The extruded shape is also easy to edit. I can use the grip to control the height. So that's easy to do. And then the corner grips allow you to customize the shape in this way as well. So it's almost like you're editing the original polyline shape. So that's very easy to modify these objects. So my other video about solids editing will get into doing subtracts and things like that. Now, a couple little clarifications. There are some misconceptions about what's a 3D solid. If you just have a line and then I extrude that, it will extrude, but if you think about it, there's no thickness to it. You know, it's only a two-dimensional plane essentially. You can always look at the properties palette to see, and that tells you that it's a surface, as opposed to the three-dimensional box objects, which are 3D solids. So a lot of times the properties palette is very helpful in terms of figuring out exactly what you have there. And if you do a polyline that's not closed, you can extrude that as well. But again, you're going to get a surface and not a 3D solid. So what's the difference? Well, you can model with either one. It kind of depends on what you want to do with it. A 3D solid is a lot of times easier to work with if you're trying to create something that has mass or thickness, because the surface is going to be more difficult if you were planning to punch a bunch of holes in it and expect it to be a solid block, because it won't. So that's kind of an important distinction between the two. 3D solids are more of the old-fashioned traditional way of modeling in AutoCAD. The surfaces are a newer concept, so you can use them. There's nothing wrong with them, and they still look fine when you go to a realistic view. You just kind of have to think about, okay, where do you want to go with this? What are you going to do with it? And if you're creating something that actually represents something that has a mass or a thickness, then the 3D solid is usually going to be easier to work with. Now I'm kind of setting up a sweep. You'll notice underneath extrude, there are some additional drawing commands: loft, revolve, and sweep. I don't use these quite as much, but sometimes they are very useful. So to do a sweep, you can see what the little icon looks like, and it gives you a hint there when you hover the tooltip. Basically takes a profile and extrudes it along a path. So it's very useful if you're doing something like a molding or a railing, etc. So I have a polyline here that's going to represent my path, and then I have a polyline here that represents the profile of what I want to sweep. Now, in order to get this oriented the correct way, I want to tilt this up so that it's kind of standing up vertically. So this is a good opportunity to think about the importance of the UCS and working in 3D. You have a couple options in how you do this. You can use 3D rotate, because you're really trying to tilt this up out of the XY plane. So the regular rotate is only going to spin this around on the floor. Like if I do this now, you can see all it does is spin it around on the ground, so that doesn't tilt it up. So I can do 3D rotate, which you can get to on the ribbon under the regular rotate. That's one option. Your other option is to use the UCS, so I'll show you both ways so you get used to those choices. So I'm going to hit 3D rotate, select my object, and then hit enter to move on. Specify a base point, and then it asks to pick the rotation axis. Basically, which one of these red, green, or blue axis do I want to use to flip this? So that would be the green one, because if you think about, that's the kind of the axis of rotation and how it's going to spin. So I'll click that, and then I'm just going to type 90, and now it's flipped it up so it's standing up in the XY plane. In other words, pointing up at the sky in the Z direction. So that's one way to do this. Now, before 3D Rotate was that easy to use, I would normally change my UCS icon so that it flips up, and that would still work fine. So I'm going to rotate my UCS about the x-axis again, and then hit space to accept 90. Now if you rotate this, it's going to rotate it in the XY plane, because as a rule, that's what always happens. So I'll do my regular rotate command now. Select my object, pick a base point, and then type my 90, and it flips it up in the same way. And then I can set my UCS back to world. So you have the two options. You can use the 3D rotate command, or just remember that your UCS icon can always be changed so that you're working in the plane that you want to work in. Now I'm going to move this over so that the corner is at the endpoint of my sweep path, and now I'm ready to do the sweep command. So I select the object to sweep, and then hit enter or space to move on, and then I select my sweep path, and it extrudes it along that path. And if I switch to a shaded view, then you can see that a little easier. So that's an easy way to get some kind of a more complex shape that needs to follow a path. Now, another handy command on the Solids tab is Revolve. And that's great for when you have things that are round, spun on an axis, almost like if you had a lathe. You can draw the half of the cross-sectional shape. So if you're thinking about something like a vase or a wheel, a candle, you know how many things are round in that way. You can draw half the cross-sectional shape and then revolve it. Now, both of these would result in the same thing. It doesn't matter if, in this case, if you have this closed with this center line of the object or not. So I'm going to hit revolve, select my object, and then move on to the next step with space or enter. And then it asks me for the axis start point. So I'm going to click the end point here, and then the end axis, the end of the axis is there. And then I specify the angle by just hitting enter to accept the default of 360 degrees. So now I have that as a 3D solid. Let me show you that in a shaded view here. So now I have a little kind of a clunky, ugly vase, but you get the idea. So that's very handy when you want to draw rounded objects. Now, those basic tools are very useful, and you can build a surprising number of things out of just those commands that I've shown you. I'm going to go through one more, and that's the press pull, which is kind of a newer thing. If you have an enclosed shape like this, and if you hover, you can kind of see the tooltip is showing you the idea here. Any closed region, you can use this to kind of extrude it up. So in the olden days, you would have to, if you want to make this, let's say you're doing a hollow object, maybe you want these to be 4 walls with a room in the center. You would have to extrude the outside box, extrude the inside box, subtract the one from the other. That would be one easy way to do that. And you still can, and I'm going to get into the subtract commands and whatnot in my other video. But now with the press pull, you can use that to, it'll recognize the enclosed region. So you don't have to do all those steps. So now it says click inside bounded area to press pull. So I can click between those two polylines, and then you can see how it recognizes it as an enclosed region, and then I can pull that up and click my height. And then again in the properties palette, if I need to tweak things, I can make my height something more specific. I could have typed the height and that would have worked as well. So that's very handy when you have some line work like that that you need to extrude. So that covers the basics of 3D modeling, and you can kind of assemble these things together to create complex forms. Now, I will say, in this kind of case, you probably don't want to, from scratch, build a 3D solid project for like a house or a commercial building or something like that. If you are serious about doing like a virtual building, then you're going to probably want to use AutoCAD Architecture and use the intelligent wall, door, and window tools. And I do plan to get to a video about that when I get time. So keep that in mind. These are great for the smaller parts of a three-dimensional virtual building, but it's not usually used for something like that. So then you would use AutoCAD Architecture for the walls, and then you add the details by these 3D solid tools.